thanks. I'm glad to come here today and tell you a little bit about a new course, a pioneering course, we think, about interstellar science, about interstellar communities and interstellar civilizations. This was something that came out of discussions with Steve Durst and others here at Ad Astra. And I said, well, you want to start Interstellar University? Well, I'm at a university. What do we do at universities? We offer courses. So we created this course that will be given for the first time in spring 23. It comes out of Wichita Space Initiative, which you can learn more about at wichita.edu/space. So the course itself will be available to everyone in every format you can imagine. So students will be able to be on our campus and show up in a room, and we can all be together for the discussions and the talks. The speakers will mainly come from off campus. They will come from all over the United States. We're trying to concentrate on Kansas because we are the Ad Astra state. So we're trying to get as many speakers from Kansas as we can. It is a high flex course, so you can take it online, remotely, while it's happening live. You can also take it asynchronously. Now, it is a college course. It is 1 credit hour. You will have to purchase the credit hour and pay tuition for that. But you will get a credit hour that you might be able to apply to a degree either at WSU or someplace else. The course is not a technical course, so there's not going to be any math or any heavy science. In fact, we have a lot of topics in the humanities and social sciences, because if you think about interstellar missions, if they're peopled, these could be multi-generational missions. What's life going to be like on a multi-generational ship? What kind of culture are you going to have? What are communications going to be like? How do we keep the crew healthy? How do we make spare parts? These are the kind of things that we're interested in. So we will talk about cosmology, talk about places like Proxima Centauri, which might be the first interstellar target for robotic missions. We'll talk about past missions and things related to in fact, the only interstellar mission right now. But we'll also mention some of the planetary things we've done as well. Exoplanets, exoworlds, exomoons, these are the places we're headed to. So we'll learn a little bit about those. How do we detect them? How do we know they're there? How do we know they have water on their surface? Or the other chemicals that we might need for life? Planetary protection is the area where I've been working. That's where I do my research with NASA. We care about salty microbes because Mars is salty and Europa may be salty. And we want to know what we're bringing with us and what it might be able to do on Mars. And we also want to know what happens when we bring things back. And when we think of interstellar missions, we're thinking about contact, perhaps. We're thinking about lots of different types of exchanges that are going to involve planetary protection and trying to keep things clean both ways. We'll talk about propulsion systems and power, both traditional systems that use rockets and those systems that use different technologies, solar sails, laser-driven solar sails, and other types of propulsion, the types of things that we're kind of practicing a little bit with one of the CubeSats for the Artemis mission, the NEA Scout, has a sail on it. So, but each one of these, of course, is a topic for a lecture. They're not full courses in themselves, so they will be relatively accessible, very broad, and not very deep in our discussions. It's to make people think about the issues that we have with interstellar travel. Of course, making spare parts along the way, whether you're a robot or you're a peopled, crewed mission, you might need to make spare parts, and perhaps you need to make additional spacecraft, like the von Neumann probes. So we'll talk about those as well. There will be discussions of radiation environment, microgravity, and other things that are important for human health. If we have crewed missions, we have to think about long-term space exposure, a lot longer than perhaps we've been doing to this point. And we'll talk about different issues with health in space, and not just physical health, but mental health as well. These are important issues. Of course, life support is important. I used to be part of a NASA center at Purdue University studying bioregenerative life support systems years ago. This is still an active area of research. And how do you feed them on long missions? Even to Mars, it doesn't necessarily make sense to bring all the food and all the oxygen with you. If you can have a recycling system like we have on our planet, that would be great. But it's much smaller, and you don't have the big atmosphere and the big oceans to buffer everything. So there's a lot of issues involved with feeding them and providing them with oxygen and recycling their wastes. Finally, we have several panel discussions at the end to talk about some of these social of multi-generational missions. We ask questions: should we send missions with people on them initially, or should they all be robotic? When do we make that decision? When do we decide that it's time to go interstellar? As we develop new technologies, should we wait because we'll get there faster and do it better? Or should we go now and soon? So I think in the end, it's going to be both of those. So that's the course. This is Interstellar Seminar. It's out of the College of Liberal Arts and Sciences. It's not associated with any particular department. If you want to learn more about it, you can look at the WHU course catalog. It's already listed there. You can write me. My address is there. I'm easy to find on the web. And you can find more information about the course. And hopefully, some of you might join us, and some of you might tell students about it. Since it's asynchronous, we think anyone, anywhere around the world, at any level, should be able to walk into this class and learn a whole lot about interstellar science.